The name of the experiment is measurement of earth resistance by earth tester. Now first of all we have to understand why earthing is required, and to understand that uh, let us take this figure. Now here is electrical equipment. The supply is given to that equipment from the secondary of a distribution transformer. So this is a neutral wire, this is the live wire, and in this system there is no earthing. So if this live wire is accidentally, if it is connected with the metallic part of this electrical equipment, and if someone touches, then current will get a closed path to flow. So this current will be flowing through the person who is touching the equipment. So as a result, this person gets shocked. But if the system is properly arced, means all the electrical equipment are or all the equipment are properly arched, then what will happen? If some live wire is in contact with the metallic part of the electrical equipment, then the current will flow through the low resistance path provided by the earthing system. So the current will flow through this path, but the current will not flow through this human body because the resistance of the human body is very high, around 15 to 20 mega ohm. But here current doesn't get any other bulb. So as a result, this human being is being protected. So it is easily understood the earthing is very, very important. Now I am showing you atomistic earthing system. So this system is seen in our house. So this is the earthing wire, and it is connected with a rod. Okay, so the length of the rod may be 6 to 10 feet, and it should be inserted into the earth. Now obviously this resistance, this earthing resistance should be very low. It is very important. Okay. Now how will I measure this earthing resistance? So measurement is also very important. So in the existing system, if I want to measure how much is the earth resistance, then I have to take the help of some meter, and that meter is earth tester. Now how it is connected. If I want to measure the resistance of the earth, so this is the basic diagram. So this is the earth tester. It will have, you will see in the lab, there are 4 terminals. These 2 terminals should be shorted and it is connected with the earth system. This fourth point should be connected with a electrode which is inserted some 10 or 20 meters away from the system. Suppose if the distance is 20 meters, then another electrode is inserted here and which is connected with the terminal 3, and suppose it is inserted at the mid point between these two. So if it is 20 meter, suppose it is at 10 meter. Now you can get the resistance directly from the digital meter. If it is low, then okay, and if it is high, then obviously the system is faulty. So you need to take some measures to decrease that resistance to 1 ohm or nearly 1 ohm. Okay. Now this is the way. Now I will show you, and this necessity I will show you another figure where earth resistance is being measured first. Suppose this is the land where some electrical substation or power station should be built up. So before we install or commission the substation, we need to find out the earth resistance in this zone. And to do that, we have to conduct the test along the 6 directions. So one in this direction, the 4 sides, and 2 diagonally directions. Okay, and we have to get the average one to get the earth resistance. Now, what do we do in our laboratory? And giving, so this is the circuit diagram, or this is the operation. So basically, RE is the voltage drop between E and P. Here it is seen E and P, and the current through the earth path. This is the working formula, and it will be seen that as the distance increases, the resistance varies like this. Now let us have a look on this circuit. This is the actual arrangement. So you can see this is the earth tester which is uh, kept in our lab. Now we'll take the help of this arc twister, and as I've said, it has four terminals. So first two terminal is shorted, E1 and P1 is shorted, and it is connected with the electrode which is inserted into the arc like this, and this E2 point, it is connected with another electrode which is inserted some 20 to 50 meter away from the first one, and this electrode which is connected with the P2 can be varied, its position can be varied from the first electrode. Now if this is say 20 meter, first this electrode should be inserted at 1 meter away from the first one, and you have to take the reading, and there is a range 10 and 1000. If the resistance is very low, within 10, I can provide this 10 ohm range, and if it is greater than 10, then I have to take this 1000 ohm range. Okay, and when this test button is pushed, then only we get the result. That means when the test button is being pushed, then supply which is inside this meter is given to the circuit. Okay, so we will directly get the reading from the meter. So what will we do? We will change the position from 1 meter to this 20 meter. Okay, and we have to note all the readings, and we have to plot the reading in a linear millimeter graph, and it will be seen that the nature of the resistance will vary in this manner. As we go towards the far electrode, it will increase, and at the midway it will be parallel to the distance x-axis, and normally the arc resistance is taken as this height, where this line becomes parallel to x-axis. Okay, so this is the experiment.